Okay, kind of a tricky problem. We are given that a cube's rate of change of the volume is 3 meters cubed per second. So we want to find this moment where the rate of change of the surface area is going to be 3 meters squared per second. Their numerical value is both going to be 3, but it's going to be different units. So we need to find when that happens, and then we're going to determine the length of the cube's sides at that point, and then also how quickly the side is changing. So first thing we should do is find dV/dt, functions for dV/dt and ds dt. So the volume of a cube, let's separate all our known information. The volume of a cube is L cubed. The surface area of a cube is 6L squared, because L squared is going to give us the area of one of the faces, and then there's 6 total faces. So dV/dt equals 3L squared dl dt, and ds dt equals 12L times dl dt. So we have 2 unknowns here. We don't know L, we don't know dl dt, and here we actually have 3 unknowns because we don't know ds dt or L or dl dt. We do know dV dt is 3. And in fact, we actually also know that ds dt is 3 because we want them to be the same. So actually only 2 unknowns in both cases. We don't know L, we don't know dl dt. So we can start by saying this equals 3, and that's equal to 3L squared dl dt. Okay, so then when we divide 3 over, we get 1 equals L squared dl dt. And then we find out that 1 over L squared equals dl dt. So now we're going to substitute. We're going to take our 1 over L squared and substitute it in for dl dt, because that's what dl dt is equal to. So now we get ds dt equals 12L times 1 over L squared. So then ds dt is going to equal 12 divided by L. But then we already know what ds dt is. We know it's 3 because it has to be equal to dV dt. So we get 3 equals 12 over L. So then L is going to have to be 4 because 12 divided by 4 is 3. But if you really want to do the algebra, you can say 3L equals 12, multiply the L over, and then divide by 3, get L equals 4. So when dV dt and ds dt are both equal to 3, the length of the cube must be 4 by this algebra we just did. That's part A. Now part B is saying what is the rate of change of the side in that moment. And we already found out the rate of change of L with respect to time is 1 over L squared. So then we can come over here and say that dl dt is just equal to 1 over 4 squared, which is 1 over 16. Now I'm kind of going into the arrow there, but we should also make sure we include units for our final answer. So we're going to say it's 1 over 16 meters per second. So at the moment when the rate of change of the volume and the rate of change of the length, of the surface area are both equal to 3, at that moment the length of the cube's sides are 4, and then the rate of change of those sides are 1 over 16 meters per second.